All right, scholars, here we go with the next one. It says find the value of x. Leave your answer in simplest radical form. First of all, I want to emphasize, if that's not a right triangle, the Pythagorean theorem means nothing to us. So we're going to go ahead and say, okay, that's a right triangle. I can use the Pythagorean theorem. So you can either go a squared plus b squared equals c squared, and I think I'm going to stay with that just because you guys are used to it. But here's what I want you to do. Which one is the hypotenuse? 8, 20, or x? Okay, so label that as your hypotenuse. It helps you figure it out just a little bit better. Then you plug in for every part. It's kind of like what we're doing with our formulas. If I write this every time and if I plug it in correctly, I'll get it right. If you don't write it every time you get it wrong, a lot of people get it wrong. So I'm going to go 8 squared plus x squared equals 20 squared. Now, if we were in class, someone should ask, how do I know that 8 goes in the A or does it go in the B? Here's the cool thing. It doesn't matter. All right, it has to go into one of them. So what I work with this one then is I go ahead and I square everything. So I get 64 plus x squared equals 400. So then we go ahead and subtract 64 from both sides. X squared is going to equal 3, the square root of 300, make sure I get that right, excuse me, 336. But how do I get rid of that squared? And this is when we take the square root. Now, just like what we did the other day, and I'm going to move it up here, so I get 300, square root of 336, we have to decide if that is in simplest radical form. And I'll tell you right now, I know why it doesn't. I can put 4 in there. If I can get 4, there's a good chance there's a larger perfect square number that can come out. So I start using my perfect square numbers to figure this out. And if you did, you would have realized you had 16. I'm going to change it to look like this. I'm not having a great time working this without having a pencil. The square root of 16 times the square root of 21 are going to be your two values. And 16 is the largest perfect square number that comes out. So what's the square root of 16? 4. So you get 4 root 21. That is in simplest radical form. That means no decimals. Did everyone hear me on this? No what? No decimals. We want to leave it in this form because I don't know how many decimal spots do you stop afterwards. This just lets you stop right where you want to. Now, the next thing is we know the Pythagorean theorem works only for triangles. So we'll even say that. Only for right triangles. And I said only for triangles, obviously, but specifically only for right triangles. But we can actually use that to help us figure out the different types of right triangles. So we have 3 forms. If I give you 3 lengths of the sides of a triangle, I should be able to decide if it's an acute, right, or obtuse triangle based off of what we know of the Pythagorean theorem. The first one is if the 3 sides of the triangle go in perfectly into the Pythagorean theorem, then I know it's a right triangle. So it looks, perfectly like this. A, B, and C. However, when it doesn't work perfectly, I should be able to figure it out a little bit more. So in the next one, if I get the following, a squared plus b squared is going to be less than c squared. Now understand, a and b are the 2 shortest sides. C is always the longest side. A, B, shortest, 2 sides. C will always be the longest. Okay, when I'm working with this, then we know if this inequality works, we have an obtuse triangle. So it should look something like this. The same sizes of like A's and B, but it should look in this manner. And the cool thing is you should always know where the obtuse triangle is because it's always opposite the longest side. But we can do the same thing for acute triangles. I can go a squared plus b squared is greater than c squared. So it looks something more like this. And we have our A, B, and C. So kind of in that manner. And we're going to imagine all these are the same size. What changes is going to be my value of C. And you kind of think of your hands like this. If I have a right angle, very easy to see. If I have an acute angle, smaller side. Obtuse angle, a lot larger side. So using our hands to help us out. But now, those are the only theorems I have for today. We're going to start practicing these. Now, we are going to go through and make sure that we know every single one of these. So we're going to go and look at it first. Is this, it says find the value of each variable, leave your answers in the simplest radical form. So if you need to put a square root symbol there to remember simplest radical form, that's great. That means every one of them has to be simplified. If you do not simplify it completely, the answer is wrong. If you can do everything up to that, that helps, but we gotta make sure we can simplify our radicals. So here I look at my right triangle, I decide which side's my hypotenuse. Which side's my hypotenuse? This side, right? So that's your C. So the first thing you should write down is a squared plus b squared equals c squared. Now some of you are like, I don't need to know this, I already have this memorized. If you do not write the formula down, many of you will mess up at least 1 or 2 problems on your homework. So I really would like for you to write it down. Then I plug in the stuff I don't know. I have x and 7 here, so I get x squared plus 7 squared equals 10 squared. So x squared plus 49 equals 100. So you subtract 49. X squared equals 51. Now, this is where we're working with it. I'm going to take the square root of both sides. Now, officially in algebra, we need to put a plus or minus there. But are we finding length? Yeah, so it has to be positive, so I don't have to worry about the minus sign this time. And then when we work with it, there is no perfect square numbers that go into 51. So your final answer is just that, the square root of 51. Now, some of you are like, but Gregerson, how do I know if that works or not? Well, you just have to try them. You have to try everything 49 on down, if it goes in or not. And like, obviously, you should go 49, 36, and 25 do not evenly go into 51. So you try all the numbers lower than that, like 16, 9, and 4. Well, they don't work. So that is in simplest radical form. Now, for time-wise, I'd love to do this one, but I want to make sure that we get through this problem here, because these two are very similar. They just look differently. But here's the thing. I still have a right triangle, and I know 2 sides. I can find the missing side of a right triangle if I have the Pythagorean theorem. Now, again, always first, I'm going to write this down. Write your Pythagorean theorem down, okay? Now, mark which side is your hypotenuse on C, okay, because we're going to do C right now. It's Z. So this time it actually goes into the missing spot. So I got 8 squared plus 14 squared equals Z squared. And I put a line through my Z's because they look too much like my 2's. Okay, so I just have to be very careful. Then I go ahead and I square everything because I'm going to do my order of operations. So I got 64 plus 196 equals Z squared. So my answer becomes, added together, 260 equals Z squared. Now, I have to take the square root of both sides, and I'm going to get lazy here. I'm not going to put the plus or minus here because I know distance has to be positive here, length has to be positive. But is there a perfect square number that comes out of 260? Now, you can try a lot of them from like 225 on down, okay? But I'm going to give you a hint. If it's an even number, try even numbers. Try 4. Try 16. Try those. And if you do, you should get the fact that's the square root of 4 times the square root of 65. So what's Z going to equal here? Z is going to equal the square root of 4, which is 2, root 65. That is simplest radical form. No decimals. All right, we're going to turn the page and we're going to keep working problems, friends.